Hello everyone, welcome to my 14th video lecture on partial differential equations. In the previous video, we have discussed about the solution of first order nonlinear partial differential equation which were of the type 3. In this video, we shall consider the first order nonlinear partial differential equation of type 4 which are particularly in the Clairaut's form. So what is the Clairaut's form? Let us see. A differential equation, if it is in the form z equal to px plus qy equal to plus some relation between p and q, that is some function of p and q. If the given differential equation, partial differential equation, which is of first order and which is particularly non-linear, so such differential equation if appears in this format, that is where the dependent variable z is on the left hand side and on the right hand side the first two terms will contain x, the term which is containing x will be multiplied, that is the term with x and p will be the first term and qy will be the second term, and the terms containing the p and q, some relation between p and q will be at the end on the right hand side. So such a form is called as Clairaut's form, that is a partial differential equation of type 4. So let us solve this equation. So first of all, we will take this equation as equation number 1. Now it is very easy to observe that the solution, that is particularly the complete integral of this equation is, that is complete integral, I am going to tell you. The complete integral is one which is having two arbitrary constant, because the differential equation is having two independent variables x and y. The solution which is having two arbitrary constant will be called as the complete integral, and the complete integral of this Clairaut's differential equation will be of the form z equal to ax, that is p replaced by a plus q replaced by b into y as it is, plus whatever relation is there between p and q, the same relation will be taken between a and b, that is a will be taken in place of p and b will be taken in place of q. So the solution particularly known as the complete integral can be obtained very easily, that is directly from the given partial differential equation which is in the Clairaut's form by replacing p with a and q with b. Now we shall verify whether this is a very complete integral or not. From this equation we can observe that, that is if we call it as equation number 2, complete integral 2, we can observe that dou z by dou x, if we differentiate on the right hand side, it is a into 1 plus b into, totally 0, it is a constant, its derivative is 0, plus it is constant, its derivative is 0. Therefore dou z by dou x, that is nothing but p equals to a. Similarly, when we differentiate the same equation 2 with respect to y, we will get dou z by dou y on LHS, on RHS 0 plus b into 1 plus 0, so that implies q equals to b. So we got the value of p equal to a and q equal to b. Substituting these two values in the given equation, we get the complete integral, that is equation number 2. So therefore we can say that the expression which we have displayed here in 2, that is obtained from the given partial differential equation simply by replacing p by a and q by b, is the required complete integral of the given PDE which is in the Clairaut's form. Now if the given PDE in the Clairaut's form, it should be noted that the complete integral, that is the finding the complete integral is very simple. It is simply done by replacing p by a and q by b in the given PDE. So it is not that much difficult work. Therefore in this case we are supposed to find one more solution of the given PDE, that is the singular integral. So it is better if we go for finding the singular integral of the given PDE which is in the Clairaut's form. Finding complete integral will be asked only for 2 marks. It is not so difficult, whereas finding singular integral is a little bit lengthy work. It is not so difficult. It is a little bit lengthy work, and we shall try to know how to get the singular integral for the given partial differential equation. So what should be done? We have to first get the complete integral. So we have to get equation number 2, as I have explained earlier. From that, we have to differentiate this expression with respect to A and B. Here it should be noted that the equation number 2 should be differentiated with respect to A. That is equation number 2 which should be differentiated with respect to A and with respect to B. And then we have to arrange the terms in such a way that we get the value of A equal to something and B equal to something. So after getting the values of A and B from these two equations and this equation number 2, we will now substitute these two values so obtained in the complete integral, that is equation number 2, and then that will give us the required the singular integral of the given partial differential equation. So this is how one can get the singular integral of the given partial differential equation which is in the Clairaut's form. So now let us solve couple of examples on this type of partial differential equations. So first example is z equal to px plus qy plus log of p into q. It should be noted that this term is a non-linear term because it is the product of the derivatives. So therefore the differential equation is a first order non-linear partial differential equation, and it is particularly in the Clairaut's form. So let us call this equation as equation number 1. Now finding complete integral is very simple. I have already told you what should be done. Replace p by a and q by b in 1. That implies z equal to ax plus by plus log of ab, call it as equation number 2, is the complete integral, is the CI. So if it is asked to find the complete integral, it will be asked only for 2 marks, then we have to do this much of work. If it is asked to find both complete integral and singular integral, and if the question is asked for 5 marks, then we should proceed further and we should get the singular integral also. And in order to get singular integral, or to find singular integral, we have to differentiate equation number 2 with respect to A and B. First, if we differentiate equation 2 with respect to A, that implies z should be treated as a constant while differentiating with respect to A partially. Therefore it will be 0 on the left hand side, and on RHS it will be 1 into x, because differentiation is with respect to A differentiation with respect to A is 1, x treated as a constant as it is, plus b is a constant, y is a constant while differentiating with respect to A. Therefore that should be made 0 after finding its derivative, plus log differentiation is 1 divided by the bracket, whatever bracket is there, that bracket, into differentiation of that bracket. A differentiation is 1, b should be treated as it is because it remains as a constant. Now after cancelling b and b, we get the value of x as minus 1 by a. This implies x is equal to minus 1 by a, or a equal to, on cross multiplication, a goes to the numerator, x comes to the denominator, minus 1 by x. So we got the value of x. Similarly, if we differentiate with respect to b for the second time, we will get 0 here on the left hand side of equation number 2, because z should be treated as a constant while differentiating with respect to b, plus equal to, on the right hand side, this is totally a constant, its derivative is 0, plus b differentiation is 1, y should be treated as a constant, so it is y into 1, plus log of this bracket differentiation is 1 by that bracket, into the bracket differentiation is a should be treated as a constant as it is, into b differentiation is 1, so it is a. So this implies a cancelled, it is 1 by b. When it is transferred to the other side, we get the value of y equal to minus 1 by b, or b equal to, on cross multiplication, we get the value of b as minus 1 by y. So we got the value of a, we got the value of b. Let us substitute them into the complete integral which we have obtained here in equation number 2. Therefore 2 implies z equal to, a value is minus 1 by x into x as it is, plus b value is minus 1 by y into y as it is, plus log of, let us write down the value of a is minus 1 by x, b is minus 1 by y, and in the next step, this implies z equal to x cancelled minus 1, minus sign here, y cancelled minus 1, minus minus plus, it is log of 1 by x into y. Let us multiply them together, so it is 1 by log of x into y, 1 by log of 1 by x into y. Finally we are writing the required singular integral, z equal to minus 1 minus 2 plus log of 1 by xy becomes minus log of xy. So it is very simple. It is how? It is log of 1 minus log of xy. Log 1 value is always 0, therefore it is minus log xy is remaining. So this is the required singular integral